Today in lesson 10.5 on page 405 of your big book, we're going to be learning how to calculate the area of trapezoids. So here's our essential question: how can you find the area of trapezoids? Any parallelogram can be divided into two trapezoids. We proved that in lesson 10.4 with the same shape and size, two trapezoids with the same shape and size. The bases of the trapezoids, base 1 and base 2, form the base of the parallelogram. The area of each trapezoid is half the area of the total parallelogram. So the area of the trapezoid is half the product of its height and the sum of its bases. The sum meaning adding them together. So if you added the two bases together, multiplied that number by the height, and then divided it in half, you would get the area of just one of the trapezoids. So this is the formula for area of a trapezoid. Area equals half times the quantity, base 1 plus base 2, times the height. Remember that parentheses mean that you're multiplying. Any number next to parentheses or variable next to parentheses means that you're multiplying. Where B1, base 1 and base 2 are the two bases, and H is the height of the trapezoid. All right, here we go. Mr. Desmond has tables in his office with tables that are shaped like trapezoids. The diagram shows the dimension of each tabletop. What is the area of each tabletop? So basically, this is a picture of the tabletop. This would be the side that's 16. This would be the side that is 0.9. And then from here to here, this line would be 0.6. All right, so now we're going to find the area. So first, wait a minute. How can you identify the bases? Well, the bases are the parallel sides, remember? So this side and this side are the bases, this and this. So the bases are the parallel sides. Okay, so, and then how can you identify the height? So the height forms a 90-degree angle with each of the bases. So that would be a 90-degree angle, and that would be a 90-degree angle. So both of these are 90-degree angles. So, I'll say the height forms a 90-degree angle. In other words, it's perpendicular. That's another word. It's perpendicular to the bases with each of the bases. All right. Find the area of the trapezoid. So there's our formula. Area equals 1/2 times the quantity B1, base 1, plus base 2 times the height. So area equals 1/2. What's our first base? Oh, I thought that was 16. It's 1.6. Sorry. 1.6 plus 0.9 times 0.6. I kind of wish they'd started with whole numbers if they're going to throw a new thing at you, but we can handle it. We've been doing fractions and decimals since chapter 1, so we're good. Area equals 1/2 times, let's see, let's stack up these. So when we're adding decimals, we want the decimals to be, we want all the place values on top of each other. And so you line up the decimals first and then the numbers around that. Okay, so 6 plus 9 is 5. 1 plus 1 is 2. I was trying to multiply there for a second, wasn't I? So that's 2.5. So now we have area equals 2.5. These two things added together just made the 2.5 times 0.6. All right, and then we go ahead and multiply. All right, so we're going to multiply, let's see, 2.5 times 0.6. Let's see, that's 30, 12, 15, and a whole lot of zeros. So, and we have 2 digits behind the decimal. So we go 1, 2 to put our decimal here. So 1/2 times 1.5. So these two together just made this 1.5. What's half of 1.5? So a lot of margin work with this. Okay, divided by 2. 2 does not go into 1. However, 2 does go into 10. So that's a 5. Right? 2. Oh, no. It goes into 14. Okay. I was thinking, wait a minute. Why when I subtract that, does that number come out so big? Sorry. 2 goes into 15. Sorry. Let's see. 7 times. Okay, there's the 10. Let's see. 2 goes into 10. 5 times. All right, now we're 0. So the answer is 0.75. 1/2 or half of 1.5 is 0.75. So the final answer is 75 hundredths. All right. Let's take a look at another one. Hopefully they'll give us some whole numbers here. Nope, it doesn't look like it. Okay, here we go. We're going to find the area of this trapezoid. So this is our area formula. A equals 1/2 the quantity B1 plus B2 times H. Area equals 1/2. We're going to substitute in our two base values. Let's see, we've got a 4.6 and we have a 9.1, or I mean 9.4. Okay, I'm going to stack these up to add them, so I'm sure to get it exactly right. So it's 10, 5, 14. So the answer is 14. So we have 1/2 times 14 times 3.5. Don't skip any steps along the way. Make sure you do each keep writing each line out. So here we've got an even number, and so right here they're thinking, well, go ahead and multiply this, take half of 14. Because of associative property of multiplication, we can do that. We can multiply any sets here of numbers, and we'll still come out with the same answer, the same product. So 2 times 14 is 7. So that's where that came from. And then bringing down that 3.5. 7 times 3.5. Okay, if we don't know it off the top of our head, we can always do margin work. Let's see, that's 35, 24. We have 1 digit behind the decimal, so we put that in there. Okay, so the area of the trapezoid is 24.5 centimeters squared. Okay, good. They're giving us some whole numbers on the next one. Here we go. Although this time they are shifting it in that they're giving us the area. They want us to find the height. They're giving us the area. The area of the whole thing is 702, what's our unit of measure? Inches squared. Okay. So 1/2 So the area is 702. 1/2 times 20 plus 34 times h. This time we don't have h. That's what we're going to solve for. Add within the parentheses. That would be what? 54. So 702 equals 1/2 times 54 times h. 702 equals, what's half of 54? Well, half of 50 is 25. Half of 4 is 2, so it'd be 27. So we have 27h. So we need to isolate this variable, this h, in order to find its value. So we want to make a 1. So we're going to divide both sides by 27 because we have, when we've got an equal sign, we can't throw the equation out of balance by doing something to one side and not doing it to the other. We have to always do it to both sides of the equal sign. All right, so then we simplify. Woo! Okay, I don't know 27 goes into 702 off the top of my head, so I'm going to do a little margin work. 27 goes into 70. 1, 2, 3. 3 would be too big because 3 times 25 would be 75, so it's going to be a 2. All right, so 27 times 2. Oh, we already know that is 54. We know that from over here. Okay, so we get 16, bring down the 2. All right, how many times does, what would end in a 2? 1, 2, 3, 4, 5, 6. Let's try 6 because 7 times 6 is 42. 6 times 7 is 42. That'd be 12 plus 4 more is 16. Excellent. So that worked out perfectly. So this is 6. So 702 divided by 27 is 26. That's where that came from. So the height is 26. So the height of the trapezoid is 26 inches. All right, let's analyze our relationship. Explain why the formula for the area of a trapezoid contains B1 plus B2. Because our bases are not equal in a trapezoid. They're never equal. The bases are never equal in a trapezoid. If they were equal, this would not be the shape of a trapezoid. It'd be a rectangle or a parallelogram or something else. Trapezoid bases are never equal. All right. So the formula is based on the area of a parallelogram, right? The formula is based on the area of a parallelogram. Okay. And that formula is area equals base times height, right? When a parallelogram is divided into two congruent trapezoids, right? So let's make that 20, 34. Okay, so a parallelogram that has been split into two congruent trapezoids, it has two different sized bases. Okay, so when a parallelogram is divided into two trapezoids, the bases are not the same size. So the base of the parallelogram So the base of the parallelogram, oh, let me get this more on the screen. That was 34 if I remember right. Is adding up, so this is the parallelogram, is adding up the two lengths of the bases of the trapezoid. Okay. So the base of the parallelogram is adding base 1 plus base 2. Make that look like a 2. All right, let's do one more before we move on to our notes. Here we go. Find the area of a trapezoid. There's our area of a trapezoid formula. Area equals, our first base is 3, our second base is 6, and our height is 4. 3 times 6, or 3 plus 6, pardon me, is 9. So 1/2 times 9 times 4. So this is the same as, they skipped a line, and we really shouldn't, times 36. What's half of 36? It's 18. So the area of this trapezoid is 18 centimeters squared. So this is how you do the homework. All right, let's take a look at 10.5 notes. And we have, okay, area of a trapezoid formula. And some examples, you write the formula, substitute the numbers for the variables, and solve. When the area is given, solving for the h, and the area is 45. We write the formula, substitute the numbers for the variables. There's really no difference. Simplify. The one thing that we have to do is we have to divide in order to get that h, isolate the variable, and in order to do that we have to divide both sides by the coefficient of h, which is 9. All right, good luck.